So we have a 2,500 kilogram truck traveling 50 meters per second hitting a 1,200 kilogram parked car, so it's at rest. This causes the parked car to be set in motion at 20 meters per second. If we assume momentum is conserved, calculate the velocity of the truck after the collision. So this is obviously a conservation of momentum problem, and because it seems like the car bounces off the truck, this is what we would call an elastic collision. To simplify, basically energy is not really lost, and of course neither is momentum, and the objects bounce. So we're still going to use our modified 4 steps to solve this problem because we have a before and after scenario here. We're going to start by setting up our data table, and we're going to find the momentum of the truck, the momentum of the car, and the total momentum. We're going to do that for before the collision and after the collision. So for the truck, it's 2,500 kilograms and it's moving 15 meters per second. So the total momentum of the truck is 37,500 kilogram meters per second. For the car, it's only 1,200 kilograms and it's at rest, so 0 meters per second. So that means that, of course, there is no momentum for the car. The total momentum is just going to be the sum of these, so 37,500 kilogram meters per second, because you added them together. So that is our before scenario. After, we know that momentum is conserved, and so the total momentum will still be 37,500 kilogram meters per second. The momentum of the car will be its 1,200 kilograms times the 20 meters per second that it's moving at now. And so the car now has a momentum of 24,000 kilogram meters per second. The truck momentum will be its 2,500 kilograms times whatever velocity it is going. So we have our data table, and now we're going to use algebra to solve this equation. We know that this is the total momentum here, and these two are going to add up to equal this. So we set 2,500 kilograms times the velocity plus our 24,000 kilogram meters per second equal to our total 37,500 kilogram meters per second. We want to get this velocity by itself, so we're going to subtract 24,000 from both sides. And we get, because the units match up, of course, get that. And now we still need to get velocity by itself, so we're going to divide both sides by 2,500 kilograms. And so velocity is equal to 5.4 kilograms cancels out, meters per second. And we have a positive number, so we don't have to worry about changing direction. It's the same direction as the car.